Welcome to solverfy.
So we have a very large slab. Let's say this is our slab with the thickness D. Because the length and the breadth of the slabs are very large, we can think of this as an infinite slab. And because of symmetry, the field must be perpendicular to the plane of the slab. Now, let's say our rho is positive, which means our electric field will be away from the slab. So now, because this is our origin, and we want to find the field at distance x, consider a cylinder surface which looks something like this. This distance is x, obviously, and this distance is d by 2. Now, we want to find the flux through this Gaussian cylinder. Now, the flux through the circular surface will be 0 because the field is simply perpendicular to the surface. There will be flux from the two circular surfaces on either side. So our flux will be the sum of the two fluxes. So there will be electric field E here, but because of symmetry, the electric field on the other side will also be equal. Let's say it is E. So that's E times the area of the surface. Let's say the radius is some r. So E into 4 pi r square, into pi r square for the upper surface, and even for the lower surface, it's E into 4 pi r square. Notice that the electric field is upwards at the top and downwards at the bottom, which means the flux in both the cases will be positive. So that's E into 2 pi r square. Now this must be equal to charge enclosed divided by epsilon naught. Now charge enclosed is simply rho times the volume. The volume of the cylinder is pi r square times 2x. Because the length of the cylinder is 2x and the area of the cylinder is pi r square, we know that the volume of cylinder is area times the length of the cylinder divided by epsilon naught. This must be equal to 2 pi r square E. Hence, from this, we can see that E is equal to, we'll cancel off a few similar numbers, given r square, giving us E is equal to rho x by epsilon naught, as long as x is less than d by 2. Notice that if x is negative, your E will be negative, which is in line with our expectation. When x is negative, we expect E to be downwards instead of upwards. Now that we have this, what about distances which are beyond d by 2? That is, what if this is our x? Then x is greater than d by 2. So we do the same thing again. We know that the flux is simply 2 times electric field times this area, which is pi r squared. This is d by 2, by the way. Now this is equal to charge enclosed divided by epsilon naught. Now charge enclosed will simply be the charge within this volume. So even though the cylinder extends beyond the slab, only the cylinder, that part of cylinder that is within the slab, will have any charge. So we only consider the charge here. So that will be rho times pi r square times d, because the part of cylinder that is inside the slab will have length of d by epsilon naught. That's it. 2 pi r square E, which gives us E is equal to, we cancel pi r square, and we get rho d by 2 epsilon naught. This is the electric field for any point beyond the slab, that is, for mod x greater than d by 2. That is it.